Welcome back, everyone. In this video today, I would like to show you another video about how to write the rational function. I found this topic is a little bit complicated, so I would like to give you at least 2 videos to show you in my course online, Math 12 with Calculus, and give you a hint how to write them correctly. So in order to write the function of the rational function, we have to know the characteristic of their behavior. And the analysis of it we went through before from those previous video. Secondly, we know the general form of transformation of on the transformation on the function in general. So the transformation of the rational function in the general form is this form here. I wrote it on the board. So y equal a divided by x minus h plus k. We also related this transformation to the characteristic of rational function. So the A here stands for the vertical stress factor. The H here in transformation stands for whether we move the horizontal to the left or to the right of the function, the x-coordinate function to the left or the right. And the k here is stand for we shift up the whole function up or down. That is according to the transformation of the function. In rational function, in the way we analyze the behavior, we can also relate this x minus h here as the vertical asymptote, and the k here as the horizontal asymptote. And we went through that before with some of the sketching and writing about that in my previous video. So here is the situation. Keep in mind all of this. We're going to establish the rational function for the image A here, the image B, and the image C. Now, in the second question, you see that this here, we supposed to write an equation, but we don't have a graph. We only have a data given. So let me go through the first one and show you how we will do this. So for the first rational function, obviously, this looks like a linear. It doesn't look like any rational function. However, when we write it, we know it is a rational function. So let's say you have a rational function, y equal. Now, because we don't see any vertical asymptote here, and we don't see any horizontal asymptote here as well. So if we use this form, it might be difficult to do that. So all what we can do is we will try to establish a function based on whatever we see on the graph here. So what do we see here? We see the home at minus 1 for x and minus 7 for y. So this is minus 5, this is minus 6, this is minus 7. And this home occurred right here. So this is the situation we know, minus 1 and minus 7. So we focus in this. What else do we focus? We also see we have an X-intercept here, which is 6 for x and 0 for y. So we try to take advantage of whatever on the graph we can take advantage of it. Now, when we have a home in the rational function, it means we have a denominator and the numerator we can cancel out. So our the x for the home here, x equal minus 1. It means we will have an x plus 1 on the top and also x plus 1 at the bottom so that we can cancel. So this is the first step we try to establish this based on the home. Second, we're going to look at the X-intercept, and we know that if we set this equation equal 0 for y, we have an X-intercept at 6. So it means on the top, we have to have a x minus 6. So that when we cancel this out, we cancel this one, we left with the X-intercept equal 6. It's right here. Now, we cannot take advantage of the k here or h here because we have no clue. We don't have any information about vertical asymptote or horizontal asymptote. This is the linear function. And on what we know is we base on whatever appear here for us to see. So if, let's assume that if I cancel this one here, obviously, you will see this is the linear function y equal x minus 6, which is exactly this linear straight line here. But because this is the rational function, so assume that this is the original equation and we haven't factored them out, we haven't canceled, this is the rational function we have. So let's multiply them together and try the equation. So this time this will give us, the top will be x squared minus 6x plus 1x will be minus 5x. So I do a very shortcut, right? So I just say x times x is x squared, x times 6 is minus 6x. Now plus 1x, so it becomes minus 5x. The last term based on 1 times 6 here will be minus 6. So that's how we multiply the top. And the bottom, we have x plus 1. Now, when we factor it, we will have this form and we will be able to cancel this one and we left with the linear function here. Now, how do we check if this established equation is correct? So let's say this is the one. And we want to know the way we can establish, we can check using the home here. And you know that for checking, we can cancel this one with this one, and we left with x minus 6. Now, what is the y equal when x equals 6? The y will be equal, what is the y equal, what is y when x equal minus 1, right here, right? We're talking about the home here to check. So we know x equal minus 1. So based on the cancellation here, we left with this. And if you check it, right, you will say, okay, minus 7 equal, if x is minus 1 minus 6, yes, minus 1 minus 6 equal minus 7. So the home here is actually true. And therefore, this is the equation we're supposed to write for the first diagram. We also realize that if the coefficient in front of x here is 1, but we have a higher degree from the top more than the bottom, it means that if we have a higher top, have a higher degree than the bottom, then we don't have a horizontal asymptote because we cannot find the y value when the x getting very large. It means there's no horizontal asymptotes. So basically, we check the whole, we check the horizontal asymptotes, everything on dry. If we check, we cancel it. We do have the X-intercept at x equals 6 and y equals 0. So everything seemed to be okay for the first diagram. And that's the equation we're supposed to write. This is the final answer. Now let's go to the diagram B. How are we going to write the equation for the B? So I'm going to answer the B here. I'm going to borrow a bar here to write the answer for the B here. Now, in the second diagram, what do we see on the graph here? We see the X-intercept here, right? And this X-intercept is what? -2 and 0. We also see the Y-intercept here. It looked like 0.5 for the Y and 0 for the X. We also see the vertical asymptote, and we also see the horizontal asymptote. So maybe we can use this form. We can take advantage of this transformation and its information because we know the value of K, we know the value of horizontal asymptote here, which is the K, and we know the vertical asymptote here, which is this line. So let's try this form. So for the B, I'm going to establish the equation y equal A over x minus h plus k. Now, I am going to substitute any value I know in this information. So I'm going to write this like y equal, now A I don't know, obviously I don't know, right? The x is just the x. Minus h is the vertical asymptote. So the vertical asymptote here is x equal 4. So it means I have to have a -4 down here because that's how the vertical asymptote occurs. The horizontal asymptote will be +1 because that is, sorry, this is the second one, right? Y equal 1 is a K value. So I have this. So substitute K by 1 because of this asymptote here. Substitute x minus h by 4 because this vertical asymptote here. That's how I do. So how do I continue? Now I have to figure out what the vertical stress factor on the top I have for this one. So I'm going to make sure that I don't have any hole in here and look like I don't have any hole in here. So whatever we see from here, we can substitute the value and find out the letter A here. Now, let's say if I pick the point of X-intercept here, right? Let's say if I pick this point. So I can substitute the Y equals 0 into the equation. The A is still A, I don't know, and Y try to figure it out. And my X-intercept is -2, so I can substitute this. Y is 0 and X is -2 in this equation. And what I have to do is solve for A. So now I'm going to solve this equation. This is 0, A over -2 minus 4 is -6 plus 1. So I'm going to move the 1 to the left side. Because that's on the right side, I'm going to kick it to the left. When I move it to the left, I have to switch the sign to opposite. Positive become -1. Equal A over -6. At this point, I can do cross multiply or I can kick this up, right? That's how I do it. Divide become multiply when you kick to the other side of the equation. So I will have minus 1 times with minus 6 equal 8. Minus 1 times minus 6 equal plus 6 equal 8. So now I can write this equation as, so this is equation B, right? Not the C. Y equal, A is 6, so I put on top. And X is just X, Y is just Y. That's how you write an equation. Minus 4. And the K here is plus 1. So this is how I answer the second diagram here. I want to check to make sure if my equation is correct. And how do I check? I want to pick the point here and substitute it to see if I get it correctly. Right? I already established the second equation, right? Y equals 6 over x minus 4 plus 1. Now, because this is a rational function, is complicated. So I just want to make sure that my equation is correct. And how do I check my equation correct? I just have to substitute 1 point on the graph to put in the equation I wrote, and then see if any contradict information or everything on right? So let's substitute the point in this equation and check it. Now, when you do that, make sure you know that we already use the X-intercept here to substitute in here, right? When we want to solve for A, when we establish the equation. And therefore, this point already used, right? Already used. We cannot use the same point because if we use the same point to check, it's like we cheating and there's nothing wrong, right? We already use that to find the equation. So now if we substitute the same point there, it doesn't mean any different. So it means that we cheat. So let's make sure that you have to use a different point on the graph, right? To see if we use a different point on the graph and we put into our equation and are they okay? If they are okay, if everything is okay, then we say, oh, we write the correct equation, right? So that's how we check it. So let's look at here. What else we can use? Now we can use this point, right? This point is the y-intercept. And we haven't used this one. So this y-intercept is 0 and minus 1/2. So let's substitute this point into this equation and see everything okay. So I'm going to use the span here. Y is, so I'm going to substitute this y by minus 1/2, right? Minus 1/2 equal. The 6 is just the 6. The x is 0 because that's how the y-intercept look like, right? X 0 minus 4 and plus 1. I'm going to solve this to see if left side equal right side. If left side equal right side, then my equation correct. I move this over. Minus 1/2 minus 1 equals 6 over minus 4. Minus 1/2 minus 1 is minus 1.5, which is we can change this become minus 3 over 2. And we can reduce this by divide by 2, this fraction. So yes, we do have a left side equal the right side. By checking it, if we use another point on our rational function to put back into the established equation we wrote before, and if everything okay, then yes, we did write the correct equation. And that's how we check. Now, we're done with the question B. So this part is just for checking, right? We will have to erase it. If you register to my online course, you will have everything, access to the paper, on the information there for you, right? Okay, so now we're done with this question B, which is wrap B here. Now I have to write the equation for the image of question C. You know, like anytime I put my ball like this, my cat is trying to open the door. And therefore, it's so annoying. He make everything is, I have to do it again. But anyway, So let's do the C here. How do we go into establish the equation for C? Now the question C a little bit different. And that's why when I show you on the information, I select the different question. None of them are the same. You can see that, right? So question C, what do we have to do? Do we have to use this form to establish our equation, or we can use another form? Let's note this. So let's see question C, how we're going to approach. We're going to use the vertical asymptote and horizontal asymptote based on this form, or we're going to establish. Now, let's look at what we have here. We have X-intercept, we have Y-intercept, we have a hole, we have horizontal asymptote, we have vertical asymptote. So there is a lot of information. If we just put our information, a little thing in here might not working out. So my intuition, and that's why I told you, this equation is a little bit complicated, right? You have to use the intuition as well to figure out what kind of approach is the best, right? To write the equation. So because we have a lot of information in here, so I'm going to establish in the way that I can find out my rational equation based on what information I know, rather than just a vertical and a horizontal like that, right? So I'm going to establish like this. We're going to have the top, we're going to have the bottom. Now, vertical asymptote is x is plus 1. So this should be minus 1. That's our vertical asymptote. What else do we have? We have the hole. So I'm going to take advantage of the hole. The hole at x equals 3. So we have x minus 3 at the hole. On the top, we have x minus 3. So we can cancel and we make that as a hole. What else do we know? If we put an A in here, because we don't know the vertical stretch factor. What's wrong with this? Now let's see. In order to have the horizontal asymptote like this, we need to have the degree on the top, right? Degree on top must equal degree at the bottom. So what is our degree at the bottom? Obviously, x times x is x squared. So if we just put like that to solve for A, it doesn't make sense because we don't have a degree on top equal degree at the bottom. So we have to do something else, which is A plus x, or we can put x plus A. This is the vertical stretch factor we don't know, right? We're going to solve for A. So this is our established equation based on everything here we know. Now we're going to try to pick up the point on the graph to solve for letter A. Let's pick the point. I'm going to pick the y-intercept here, right? To make it easy. Because I know y, so I'm going to substitute y by minus 1. And I'm going to substitute the x by 0, because that's how y-intercept look like. And x is 0, minus 3. Down here, we have 0, minus 1, times with 0, minus 3. Now, obviously, we can cancel this, right? Because they're in bracket. So we left with what? We left with minus 1 equal A over minus 1. So basically, minus 1 equal minus A, right? A divided minus 1, same like minus A, right? So minus 1 equal minus A. What does that tell? You can change the sign of both of them because the balance side is still the same if we do that. Whatever we do to the left, the same we do to the right. So we can switch them, both of them. So now we know A equal 1. Let's substitute in here to establish our equation because now we know A equal 1. So we have the equation look like this. So So let's see what else we're going to do. Now, this is the rational equation based on this. But what else what we should do? Make sure our equation correct, so we're going to check first, right? So this is the part of checking. Now, when we checking, because we already use the y-intercept, we substitute some for a. Now we use the x-intercept, right, to check. So x-intercept, it means I'm going to use a point minus 1 and 0. So substitute in here, we have y equals 0. And our x-intercept is minus 1 plus 1 times with minus 1, minus 3. Down here, minus 1 for x, minus 1, and minus 1, minus 3. Now, obviously, this is exactly the same bracket. We're going to cancel out. Let's see if we have left side and right side. Now, our left side is 0. Our right side is 0 over minus 2. Now, what is 0 divided by minus 2? Of course, it's 0. So, yes, left side equal right side. So, we don't have any problem when we substitute a point into our equation and we establish and we check and left side and right side. So, everything looks good. So, now we know for sure that this equation is correct after we check. So, what I'm going to do now? Now, because we try, the question asks us to write the rational function. And so we assume that we're not going to factor out like this. Everything has to be like the original, right? So let's multiply them through and write the equation. So the equation will be y equal x times x is x squared. X times minus 3x plus 1x is minus 2x. 1 times minus 3 is minus 3. That's on the top. Bottom, we will have x times x is x squared. X times minus 3 is minus 3x. Minus 1x is minus 4x. And the last one will be plus 3. So this is the equation for our graph right here. And we already checked it and everything okay. We have a vertical asymptote at x equals 1, the whole at x minus 3. What else? We already checked, so should be okay. So that is the equation for the graph C. So now we're going to do the question 2, and that's the last question in our video. So let me, okay, so I'm going to be using this space, right? I'm going to use the space to do the last question. So our last question is say, write an equation for a possible f of x rational function, right? I'm using here should be rational f of x. Have a home at 3 plus 2. Sorry, 3 comma 2, vertical asymptote equal 1, x-intercept equal minus 1. Okay, so our function will be f of x. Vertical asymptote is at 1, so let's establish that. X minus 1, right? That's the vertical asymptote. X-intercept at minus 1. A whole at 3 and 2. Okay, so we have a whole. Let's take advantage of that. A whole at x equal x. A whole at x equal 3. It means our x is minus 3 on at the bottom, on top x minus 3. What else do we have? Vertical asymptote at 1. Now, it doesn't say anything about horizontal asymptote, right? It doesn't say anything, except that we know that our x-intercept equal -1. So let's say our x-intercept is x plus 1, because if we set this equal 0, right, what did it look like? We cancel this and cancel that because at home, then our x-intercept equal -1. So it means this numerator equal this 0, so x plus 1. I mean, when we solve for it, we do have x-intercept equal -1. And that's why we put this bracket in here, right? Okay. So it looks like this is our equation, except that we don't know is that correct or not. So we're going to have to write down and check, right? Okay, so let's say this is our established equation. And it doesn't say anything about horizontal asymptote. So we can create an equation, have a horizontal asymptote equal 1 or doesn't have it. It doesn't matter, right? But we know we have to have a home. So we have to have these two brackets for sure. So let's say if we use a home, okay? If we use a home to check our equation. Now we do have an x-intercept equal -1, so we have to have a situation like this. X plus 1, 0. Okay, let's say if this is the correct equation, okay? We'll check the home to see if it works. Now, make sure I don't confuse, right? I look at this all the time. What do I do? And it looked like these two equations very much the same. X-intercept and -1. It looks like I am writing the same equation, except that we don't have a horizontal asymptote here. Okay. So a home at 3 over at 3 and 2. We don't have the horizontal asymptote. That's the only difference, right? We don't have the joint equation for a possible rational f of x with a hole at 3 and 2, vertical asymptote with 1, x-intercept equal -1. Okay, let's check to see if our home can be right. Okay, so if x equal 3, y should be equal 2. Let me put in y equal 2 in here. And our x is x plus 1. If our x is 3, our x is 3. So 3 plus 1 times 3 minus 3. All of this over 3 minus 1 3 minus 3, and never care, this is gone. So this will down here will become 2. So now I'm going to kick this up. So 4 equal 3 plus 1. So yes, left side and right side. So it looked like correctly if we put the hole in here and we check. So this is our a tabless equation. So you can see that actually this question is the same like this one here, except that here we use a graph and here we use the information. We don't have the graph. We assume that we don't have the graph. Nothing is contradict. We're missing the information data, which is horizontal asymptote 1, but we're not going to use it anyway. So everything seems to be correct. So that is the way we write the rational equation. So I hope that you enjoy my video and stay tuned for the next video. Now, the next video, I am going to help you about solving rational equation. And I think that's the last lesson in our unit of rational function. Oh, there's a lot more interesting stuff, which is the application of rational function, which is I will show you how to solve the equation of rational function, and I also show you how to solve the application, the word problems involving the rational function. So thank you for watching, and bye for now.